Welcome back everyone. So in the last video we solved jump game 2 and in this video we are going to solve H index, which is a medium question. So let's dive in. So we are given an array of integers citations where citations at I is the number of citations a researcher received for their ith paper. Now we have to return the researcher's H index. Now according to the definition of H index on Wikipedia, H index is defined as the maximum value of H such that the given researcher has published at least H papers that have each been cited at least H time. Okay, so let's understand the question using example 1. Okay, so in example 1 there are 5 research papers. Okay, and we have to return the H index. And what is H index? H index is defined as the maximum value of H such that the given researcher has published at least H papers that have each been cited at least H time. So the first thing is, what is the maximum value of H we can have? So it is given that let's say H is 5, then there has to be at least 5 research papers who has at least H citations. So if I say for example 5 is the H index, then there has to be 5 research papers who has at least 5 citations, right? But we have research paper is 5, so the maximum H that we can have is 5. Now in example 1, let's say I am saying that H is 5, maybe 5. Okay, so let's count the research paper who has at least 5 citations. So there is only 2, that is at index second, this one, and fourth index. But these research papers are not greater than or equal to 5. So 5 cannot be the answer. Now let's say I say 4 is the H index. So if I say 4 is the H index, then there has to be at least 4 research paper with at least 4 citations. Okay, so numbers greater than 4 are 5 and 6. This is only two numbers which is not greater than equal to 4. So 4 cannot be our answer. Now let's say 3. So when I say 3 as an H index, there has to be at least 3 research papers who has at least 3 citations. So the first research paper is first one, then third one, and then the fifth one. So there is at least 3 research paper. So 3 will be our answer. Now we will solve this question using two approaches. The first approach, you might have already guessed that when I was saying that what is the maximum H index we can achieve. So in the first case, the total elements are 5. So 5 might be the maximum H index we can achieve. So we will solve this using two approaches. The first one will be the naive approach. We will guess, okay, that length that is 5 might be the H index. If it is not, we will reduce and keep on checking. And in the second approach, we will use bucket sort to solve this problem. Okay, so let's understand example 1. Okay, so in this example, the total number of elements are 5. So what can be the maximum H index? So H index, if I say is 5, then there has to be at least 5 research paper with citations greater than equal to 5. But the research paper we have is 5. So the maximum H index we can achieve is 5, right? So let's say H index is 5. But for an H index to be 5, there must be at least 5 research paper with citations greater than equal to 5. But we have only one research paper this and this one research paper where the citations are greater than or equal to 5. So H index cannot be 5. So let's say it is 4. So in case of 4, there has to be research paper with citations greater than or equal to 4. But we have only two element who has citations greater than or equal to 4. So 4 cannot be the H index. So let's say 3. Now in case of 3, there has to be at least 3 research paper with citations greater than or equal to 3. So the first research paper is this one, the second one is this one, and third one is this one. So there are at least 3 research paper. Okay, so 3 is our maximum H index that we can achieve. Okay, now let's see example 2. Okay, so in this example, what is the maximum H index we can achieve? Is 3. So there has to be 3 research paper with citation greater than equal to 3, but there is only one research paper with citation greater than equal to 3. So 3 cannot be the H index. So we say, okay, 2 might be the H index. So there has to be 2 research paper with citation greater than equal to 2, but there is only 1. So 2 cannot be the H index. So let's say 1. So there has to be 1 research paper with citation greater than equal to 1, but we have 3. So 1 is the H index for this given array. Okay. Okay, so now let's implement code for the naive approach. So the size is citations.size. Maximum h that we can have is, let's say, size, and it can go up until 1. Okay, h minus minus. Now we want to count the total research paper who has at least h citations. Okay, so total h citations is initially 0. Now we'll run the loop once again. Auto n of citations. So the total hc will be plus equal to, if this number n is greater than or equal to h, then we will add 1 to the total hc, else we will add 0. Now if total hc is greater than equal to what, h, then we will return h. So let's say if I am saying that the h index is h, then there has to be at least h research paper with citations greater than equal to h. So we loop over n citations, and if the I research paper has citation that is n which is greater than equal to h, then we will count it as a valid research paper. And if the total research papers are greater than equal to h, then this is our maximum h index, because we are traversing from size to the lowest value, that is up until 1. And now if we traverse through whole array and we didn't return any value, it means that the size of the citations is 0. In that case we'll return anything, but this will never be the case because the length of the citations array is at least one element as per the constraints. But yes, in one case it might came out of the loop. For example, there are 10 research paper and all of the 10 has 0 citations. So in that case h will be 0. So we must include h is greater than equal to 0. In that case it will never come to 11. Okay, 11th line. Because if all the research paper has citation equal to 0, then when we say that h is 1, then there has to be at least one research paper with citation greater than equal to 1. But since all are 0, in that case the h will be 0. Okay, so now let's see if this works or not. Okay, so our initial test case has been passed. Now we will submit and our solution is accepted. Now we will see the second approach. Okay, so let's see first example itself. So how does this bucket short algorithm will help us to find the citations? So first we'll create an array which has a size 1 greater than the actual size. So we have the size as 5. So we'll create a 6 element size. 2, 3, 4, 5 and 6. Why 6? Because we can have h can be 0, 1, 2, 3, 4 and 5. So this is h. So this is 0, 1, 2, 3, 4 and 5. Okay. Now we traverse this array. So in the first pass, we will check if this element can fit inside this array. So this is 3. So this can fit at this element position. So we say there is one element which is equal to 3. Now we say 0. Okay, there is one element, we say 6. So this element is greater than the last element. Okay, so when we say h is 5, so this is 5. So we have to count all the research papers which has citations greater than equal to 5. So this element can be included inside this bucket. Okay, now 1, we have one element as 1, then we have 5. So this is 2. Now all these are 0. Now we traverse from the end of this array. So when I say h is 5, is it? So if h has to be 5, the total elements or the total research paper greater than or equal to this h has to be 5. But there is only 2 elements. Okay. So h cannot be 5. Now when I come at this point, okay, and I say okay, h can be 4. So the total number of research paper who has citations greater than equal to 4 has to be 4. But how many are those? That is 0. Okay. 0 is the number of elements which are equal to 4 and these are 5. So we have to count these also, because these research paper have citation greater than equal to 5. So 0 plus 1, that is, sorry, 0 plus 2. So these are 2. So 4 cannot be our answer. Now at this position, when I say 3 is a H index, then there has to be at least 3 research paper who have citations greater than or equal to 3. So how many research paper have citation greater than equal to 3? That is 1 for this, 0 from this, and 2 from this. So we have total 3. So our H index is 3. Now let's see one more example. So let's say, okay, so in this case the total length is 7. So we'll create 1, 2, 3, 4, 5, 6, 7. Okay, 7, and total length is 7. So H index can be 0, 1, 2, 3, 4, 5, 6, 7. Now we want to know whether 7 can be the H index. Okay, so if we just put the elements in their bucket, we'll be able to count, okay, how many elements. So for example 3, so we have 3 as one element here. So when I say at index 3 there is 1, which means there is one element which has a value equal to 3. But let's say we have this as 9, okay, this as 9. So where should I put? So I will be putting this in the last bucket, because element greater than or equal to this 7 will lie in the last bucket. So in each bucket we'll add the element if it matches the value. So for example, in this bucket we will add only elements whose value is equal to 3. In this bucket we will put elements whose value is 4. But in the last bucket we'll put all the elements greater than or equal to 7. Okay, so first 2 we have one element, 1 we have one element, 3 we have one element, 5 we have one element, 9 we have one element, 4 we have one element, and 5 is again there. So we have two element. For 0 we have 0 element. Now these are our buckets. Now as per the question we have to find this H index. So we'll start with the last. Is 7 the H index? So we have to find all the research paper who have citations greater than equal to 7. And that's the reason we put all the values greater than 7 in this last bucket. So the last bucket will hold all the values greater than or equal to 7. Okay, so we have only one value, so 7 cannot be H index. Is 6 or H index? No. The total research paper greater than equal to 6 are 0 plus 1. These are only 1. 5, this is only 3. So 2 plus 0 plus 1. For 4, that is 2 plus 1, 3 plus 1, 4. So yes, 4 is our H index. That is also maximum. So we will return 4 as our H index. Now let us implement this code. So let's create vector of int bucket short. Okay, so this will be of size plus 1 with all field to 0. Now for each value less than sj I plus plus, if the citations at I is greater than or equal to the last element, then we will insert this in last. Okay, so bucket short for this size element will increment to 1, else size of this element, so this element is this one, will increment its frequency. Now finally we'll keep on counting the elements from last toward the start. Okay, so for int I is 0, I is less than sj I plus plus, we'll first count bucket short at this I. Now we check if this count is greater than or equal to I, then we'll return this I. Okay, and we have to start from sj greater than equal to 0 and I minus minus. Okay, and finally we'll return, we can say the citations or the H index is 0. Okay, we fill the buckets. Okay, so if the elements or the citations at ith index is greater than size, then we will put this element inside the last bucket, else we will increase the frequency of the citations. Now at this point, we will start from the end. Okay, we'll start from the SZ. So we say if I is the maximum H index that we can achieve. So count is the addition of all the elements from the last toward the first. So initially it is 0. So count will be the sum of the elements at I, that is SZ, that is the last value. Okay, so count, and if this count is greater than equal to I, and what is I? We are assuming that I is the maximum H index when we can achieve, and if this condition is true, then I is the maximum H index. Okay, now to the previous position, and in doing so we will add all the elements inside this bucket to the count. Okay, now if this count is greater than equal to I, then I is our H index. Okay, finally we will return 0. Okay, let's see if this works or not. Okay, so our initial test case has been passed. Now we'll submit this and our solution has been accepted. Now just to recap, we saw two approaches. In the first approach, we assume that okay, H index can be from SZ to 0. So we'll start with SZ and we verify whether it is the H index by traversing the array once again in nested loop and checking whether the total count of research paper whose value is greater than equal to that H. Okay, and if it is, then we'll return that H. Okay, in the second approach, we use the bucket sort. So what we did in bucket sort, we put the elements inside this bucket. So if elements or the citations at I is greater than equal to SZ, we put that value inside the last bucket, else we just increase the frequency. And finally, we'll start from the end. So if we say that I is the maximum H index we can achieve, then the count of the research paper must have value greater than or equal to I. And if it is, then we'll return I, else we'll continue on the loop. So that's it.